Hello everyone! The topic of this lecture is heterogeneous volume objects. In this lecture, we will recall the models of volumetric and heterogeneous modeling and its application areas. Then, let's take a closer look at the constructive hypervolume model with constructive texturing. As an example of using this model, we will consider the geological model, and finally, the features of this model will be considered. Let's look at this beautiful picture. What is the secret of this 3D dragon? What do you think? The secret of this dragon is the following. This 3D object is empty inside. These are only textured surfaces without volumetric filling. Let's look at another example. Such simple and typical things in our life often have a complex microstructure and consist of several materials. Thus, it's very difficult to replicate natural objects as 3D models and produce them as a similar object with an internal microstructure. As we remember, for modeling such nature objects and for modeling physical and abstract objects and phenomena, we use point sets with attributes. Attributes of these objects can model properties of physical objects, such as photometric properties, opacity, color, reflectance, or material, density, temperature, and so on. So, volume model is presented as 3D point set with point attributes. Each point in this model is presented as tuple of point coordinates in 3D space and array of attributes. This is a list of prerequisites for creating a unifying model for heterogeneous volume modeling. Modern manufacturing technologies require mathematical models and software tools for modeling internal structure with non-uniform distribution of material and other properties, for physical simulations, geological and medical modeling, and so on. This and next few slides show the application areas for such unified volume models. It's fabrication of objects with multiple materials and varying material distribution. Physics-based simulation for the analysis of physical fields distribution over the given geometrical areas. Medical examination and surgery simulation using computer tomography and other scanning devices, and visualization of objects with varying optical characteristics, amorphous and gaseous phenomena. Let's consider volume models. The first one is constructive volume geometry. This is an algebraic framework used to model complex spatial objects using combinational algebraic operations. Spatial object is defined as tuple of scalar fields. Opacity field specifies subvisibility and geometry. Operations such as union, intersection, difference, and blending can be applied to the opacity field. But it has no relations over objects, like as collision or inclusion, and so on. You can find more information about this model in this article. The second model is object model. This model includes all the characteristics and attributes of an object. Geometry is considered the most fundamental attribute of an object, but the geometry is only represented by the boundary representation. You can find more information about this model in this article. Let's define the requirements to a volume model. The first one is separation of geometry and attributes. Then ability to model of the photometric, physical, and other attributes. Next is uniform treatment of geometry and attributes. Also, constructive modeling of both point set, geometry, and attributes using primitives, operations, and relations. One more requirement is using discrete and continuous fields for modeling. Finally, spacetime and multidimensional modeling capabilities. Such model which satisfies above-mentioned requirements was proposed by Professor Alexander Pasko in this article. It's called Constructive Hypervolume Model and used for description of the heterogeneous objects. The model consists of the geometry described by function representation and attributes described by function representation too. The constructive hypervolume model has independent representations but uniform treatment for the geometry and for attributes. Geometry and attributes are constructed using primitives based on the real-valued functions or scalar fields and operations and relations. Term hypervolume means multidimensional modeling. Using this model, we can do constructive solid texturing. We can define photometric attributes such as color, opacity, diffuse and specular reflections, and so on for 3D objects. Here you can see an example of applying of the hypervolume model construction, and in particular the constructive solid texturing. The left image shows the geometry, the right image shows the attribute space partitioning. By combining these two parts, we can obtain a complex heterogeneous object with texture. Such texture can mean a different distribution of materials or properties inside the object. This is second example of constructive solid texturing, where the transparency of the first object is used with the union of the second color object. And two more examples of the constructive solid texturing. We can apply different mappings of set theoretic operations during constructive solid texturing operations. Let's consider it with union. In the example above, we have two cubes with different solid textures, upper left image. We can combine it with a simple priority or min-max operations, or using a special function that will calculate the value of the resulting texture in each point in space. This is an example of blending union operation. It can be rendered in different color schemes. Now let's consider the construction trees of the constructive solid texturing on this 3D model of an aquarium with fish. Here you can see two construction trees of the previous 3D model. The first one is construction tree of the geometry left image, and the second one is the tree which defines textures. On this slide on the right you can see an inverted 3D model of our aquarium. This inverted model provides insight into the modeling process. This slide shows such approach as constructive time-dependent texturing. We can apply additional deformations of geometry of the model and properties inside the object and get different result shape with different texture. In this example we have a parallelepiped, top left image, and a sequence of transformations, next images. Multidimensionality in constructive texturing can be reached by adding a time as a parameter in the model. Here you can see an example of the multidimensionality in constructive texturing. These are rendered shapes in 3 different time points. The hyperfun modeling environment contains an extension with an implemented constructive hypervolume model and constructive texturing. An additional array S was introduced, which describes the attributes of the target 3D object. This is an example of description attributes of model using hyperfun language. More complex example of using constructive texturing is geological model. The model was modeled using hyperfun. The model contains of several homogeneous layers of different materials. A point set is a full block between the flat bottom and the top surface. Layers are modeled as discontinuous attribute functions. The complex cut and the well were modeled by set theoretic operations under geometry. Attributes are redefined in the well and along the edges. Such constructive texturing can be used in texturing boundary representation by algorithms of polygonization. The main features of constructive hypervolume model are listed on this slide. The first one, uniform definition for point set and attributes. The second one, the constructive trees exist for geometry and each attribute. The third one is space-time and multidimensional texturing. Also, this model has geometry independence because it can be translated to boundary or voxel representations. And finally, this model can be used in multi-material rapid prototyping. And in the end, I'd like to show one more beautiful example created with constructive hypervolume model in hyperfun software. You can read more about the constructive hypervolume modeling approach in this article.